Good day, everyone. Welcome back, students. This is Doc Gilmac, your math teacher. Are you excited? So if you're excited, just sit back, relax, and listen carefully to the topic to be discussed for today. Are you ready, class? So if you're ready, let's begin.
Two methods of describing a set. Before discussing the topic for today's lesson, let's have first a simple recall on the topic discussed to you last time. What is a set? When we talk about set is a well-defined collection of distinct objects. What do we mean by well-defined? Well-defined sets since we can be able to determine whether or not an element belongs to a set. We name a set using capital letters. So take note of that. Consider the two methods of describing a set. Number one, we have the roster or listing or tabular method. In this particular method, elements are listed or enumerated. It is preceded by a comma and enclosed with braces. For example, set A is equal to A, E, I, O, U. Set B is equal to 1, 3, 5, up to 11. Set C is equal to Sunday, Monday, up to Saturday. Notice about the three dots here. What do we mean by the three dots? This is what we call the ellipsis, which indicates that there are still elements in between the given elements of the set. If there are too many elements, we can use ellipsis. So take note of that. Number two, we have what we call the rule or defining property, or what we call the Selfbuilder Notation. In this particular method, elements are not listed or enumerated. Only the properties of a set is described. For example, set A is equal to the set of X such that X is a vowel. Set B is equal to the set of X such that X is an odd number less than 13. Set C is equal to set of a day in a week. So as you can see, properties of a set is described in this particular method. Also, in rule or defining property or Selfbuilder notation, take note class, it consists of a pair of curly braces, a variable, a vertical bar, which means we read as such that, and a sentence that describes a common characteristics of the variable. So take note of that. Consider the roster or listing or tabular method. From here, we have set A and set B. Is set A equals 1, 2, 3, 4 the same as set B equals 4, 2, 1, and 3? Why? Yes, they are the same. Because, take note class, the order of elements in a list does not matter. So A and B are the same sets. Another example for the roster or listing or tabular method, consider set C is equal to 1, 3, 3, 2, same as D, 1, 2, 3. Are they the same? Why? They are actually the same. Okay, take note class. Repetition of elements does not matter, but in writing the same elements in a set, it should only be written once. So as you can see here, set C have 3 elements that are repeated, okay, which indicates only one element, which is 3. So take note of that. Consider exercises number 1. Since we are done with our lecture on the 2 methods of describing assets, this time we will be having a simple drill applying what we have learned a while back. So consider exercises number 1. Write the roster or listing notations of the following set builder notations. Number 1. Set A is equal to the set of X such that X is an even prime. Number 2. Set B is equal to the set of X such that X is an odd counting number greater than 1 but less than 13. Number 3. Set C is equal to the set of X such that X is a distinct color of the rainbow. Number 4. Set D is equal to the set of all days in a week. Number 5. Set E is equal to the set of all odd counting numbers between 1 and 3. Since this is just a practice drills, I will just give you around 1 minute to try to do these drills. Are you ready? So your timer starts now. Alright, time is up. Let's consider our answers in these given exercises. For number 1, set A is equal to the set of X such that X is an even prime. We have only one element for set A. 2 is the only even prime number. So take note of that. For number 2, set B is equal to the set of X such that X is an odd counting number greater than 1 but less than 13. So we have set B is equal to 3, 5, 7, 9, and 11. 11 is less than 13. Number 3. Set C is equal to the set of X such that X is a distinct color of the rainbow. So we have set C is equal to red, orange, yellow, green, blue, indigo, and violet. For number 4, set D is equal to the set of all days in a week. So set D is equal to Sunday, Monday, Tuesday, Wednesday, up to Saturday. Number 5. Set E is equal to the set of all odd counting numbers between 1 and 3. Take note, odd counting numbers between 1 and 3 have no elements for letter set E, I should say. There is no element, so it is simply an empty set. This symbol, 2 braces, close and open braces, and empty or free, I should say, is what we call a null set or an empty set that contains no element. So take note of that. Consider exercises number 2. This time, you're going to write a possible set builder notation of the following given roster or listing notations. So number 1, set F is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 2, set G is equal to FARDY. Number 3, set H is equal to 5, 10, 15, and 20. Number 4, set I is equal to LOVE. Number 5, set J is equal to 3, 5, and 7. Again, this is just a practice drills. So I will be giving you around 1 minute to try. Are you ready? So your timer starts now. Alright, time is up. So we're going to have the answers for these given exercises. For number 1, set F is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Set F is just equal to the set of X such that X is a counting number less than 10. For number 2, set G is equal to FARDY. We have set G is equal to the set of X such that X is a distinct letter of the word Faraday, or G is equal to the set of distinct letters of the word Faraday. Number 3, set H is equal to 5, 10, 15, and 20, wherein we have H is equal to the set of X such that X is a counting number divisible by 5 but less than 25. Or we can say that H is equal to the set of counting numbers divisible by 5 less than 25. Number 4, set I is equal to LOVE. Set I is just equal to the set of X such that X is a distinct letter of the word love, or I is the set of distinct letters of the word love. Number 5, set J is equal to 2, 3, 5, 7. Okay? Wherein J is just equal to the set of X such that X is a prime number less than 11. Or J is equal to the set of prime number less than 11. Again, class, I hope you learned something for today's session. Next meeting, I will be discussing more about sets. Before I'm going to end this session, let me first read to you a simple Bible verse coming from the book of Psalms, verse 15, chapter 50. Call on me in the day of trouble. I will deliver you, and you will honor me. Take note, class. Skills are developed through constant correct practice, and there will always be a room for improvement. Again, class, see you in the next lesson. Keep safe, everyone, and may God bless us all.